Hi, and welcome to study session 2 covering the 2021 IRC sections R301 and R302 covering building planning 1. I am Dave Kilgore. I'll be your host and lead you through this presentation on the study session 2. Our objective today is to gain an understanding of the design criteria to be used in the application of prescriptive provisions of the International Residential Code, the IRC, including wind and seismic limitations, snow loads and live loads, as well as the methods for addressing buildings requiring some degree of fire resistance rated construction. Our reference today is going to be sections R301 and R302 of the 2021 International Residential Code. Our key points today: what is the definition of light frame construction? Under what conditions must such construction be designed in accordance with accepted engineering practice? What design standards are identified as acceptable alternatives to the prescriptive structural provisions of the IRC? At what wind speed must the structural system be designed based on a source other than the IRC? And what design standards are acceptable for residential wind design? What is the most common design wind speed in the United States, and what are the hurricane-prone regions? How is the appropriate wind exposure category determined? Which category is assumed unless the site meets the definition of another category? What are the two methods of establishing wind speed, and how do they compare to each other? Which method is used for the IRC? Buildings constructed in which seismic design categories are subject to the seismic provisions of the IRC, and which category requires design to the requirements of the IBC, the International Building Code? In which seismic design categories are irregular buildings required to be designed, and how is an irregular building determined? What alternate methods are permitted in the determination of a site's seismic design category? What is the maximum snow load permitted when using the conventional construction provisions of the IRC? What are the limitations on story height for various types of construction methods? What is a dead load? What is a live load? What is the design live load to be used for sleeping rooms? How about for rooms other than sleeping rooms? How is an uninhabitable attic defined? A habitable attic. How does the minimum live load for attic areas differ based on roof slope? How about based on the attic's use? What is the maximum deflection permitted for floor structural members, for floor roof rafters with the ceiling attached directly to the bottom of the rafters? What is fire separation distance and how is it measured? For non-sprinkler building, at what fire separation distance from an interior lot line do exterior walls not need a fire resistance rating? For a sprinkler building, if a rated wall is required, what's the minimum required rating of the wall? How far must a projection be located from an interior lot line? At what fire separation distance are openings permitted in exterior walls, and where is the amount of openings limited? Under what condition may the exterior wall of an accessory structure located on the property line have no fire resistance rating? How are penetrations of exterior walls required to have fire resistance rating be addressed? What minimum required fire resistance rated separation is mandated between townhouses? And under what conditions are parapets required? When is structural independence of the fire separation wall mandated? In a two-family dwelling, how must the two units be separated? Where the separation is horizontal, how is the supporting construction regulated? How are penetrations of dwelling unit separations required to be protected? How must a private garage be separated from the residence? Under what conditions are openings permitted? And what type of door is required? How are duct penetrations to be addressed? What type of protection is required for enclosed accessible spaces under stairways? How are interior walls and ceilings regulated for flame spread, for smoke development, and what special requirements apply to insulation? Where is fire blocking required? And what materials are acceptable for fire blocking purposes? Where is draft stopping required? And what materials can be used for draft stopping? What clearance is mandated between combustible insulation and recessed luminaires? As you can see, this is a pretty intense chapter. So chapter 3 is huge, covers a lot of ground. As you're going to see, just sections 301 and 302, the building planning portion of it, it's very extensive. So let's dive in. So our topic is application. We're going to cover the IRC R301.1. Buildings and structures and parts thereof shall be constructed to safely support all loads, including dead loads, live loads, roof loads, flood loads, snow loads, wind loads, and seismic loads as prescribed by the IRC. The construction of buildings and structures in accordance with the provisions of the IRC shall result in a system that provides a complete load path that meets all requirements for the transfer of all loads from their point of origin through the load-resisting elements to the foundation. Buildings and structures constructed as prescribed by the IRC are deemed to comply with the requirements of section R301.1. So in structural design, loads are generally divided into 3 categories. Gravity loads, which act vertically down, uplifting loads acting vertically upward, and lateral loads, which act horizontally. All structures should be built to support these loads and provide a complete load path capable of transferring these loads from their point of origin through the appropriate load-resisting elements and foundation and ultimately to the supporting soil. Any building that's been constructed in strict compliance with the IRC is deemed to provide a complete load path. Load path that is either incomplete or inadequate will expose the structure to damage just as surely as will an undersized structural member. Alternative provisions, section R301.1.1. As an alternative to the requirements in section R301.1, the following standards are permitted subject to limitations of the IRC and the limitations therein. Where engineered design is used in conjunction with these standards, the design shall comply with the International Building Code. 1. The American Wood Council Wood Frame Construction Manual, or 2. The American Iron and Steel Institute Standard for Cold Form Steel Framing, Prescriptive Method for 1 and 2 Family Dwellings, AISI S230, and 3. ICC Standard on the Design and Construction of Log Structures, ICC 400. Although the International Residential Code is intended to address most structural conditions encountered in residential construction, it may be advantageous to utilize more comprehensive prescriptive design methods that are set forth in various industry standards. So you have the Wood Frame Construction Manual and the Standard on the Design of Construction of Log Structures here. We're utilizing engineering design along with the Wood Frame Construction Manual, Cold Form Steel Design Manual, or ICC 400, which is the Standard on Design for Construction of Log Structures, The design criteria must be in accordance with the IBC, the International Building Code. The IBC becomes the design basis in those cases where the prescriptive provisions are not used. Construction systems and design, IRC 301.1.2 and R301.1.3. The requirements of the IRC are based on platform and balloon frame construction for light frame buildings. The requirements for concrete masonry buildings are based on a balloon framing system, which is down here, shows the balloon framing. When a building of otherwise conventional construction contains structural elements exceeding the limits of section R301 or otherwise not conforming to the IRC, these elements shall be designed in accordance with accepted engineering practice. So the light frame construction is a type of construction whose vertical and horizontal structural elements are primarily formed by a system of repetitive wood or light gauge steel framing members. Platform construction is defined as a method of construction by which floor frame bears on load-bearing walls that are not continuous through the story levels or floor framing. In balloon framing, the wall systems extend beyond the floor line. If you can see this, you can see the beam there, the joists, flooring, and then walls are built on each of those. The balloon framing, the walls are open all the way up from the foundation clear to the attic area. There will be times when the methods or materials used in construction do not conform with the prescriptive structural provisions of the IRC. In such situations, it is acceptable to use an engineered solution to satisfy the requirements of the code. So, moving to climatic and geographic criteria based in IRC R301.2. Buildings shall be constructed in accordance with the provisions of the IRC as limited to the provisions of section R301. Additional criteria shall be established by the local jurisdiction and set forth in table R301.2. Table R301.2 is designed so that jurisdictions recognize and use certain climatic and geographic design criteria that vary from location to location. Communities are directed to complete the table with a variety of factors. The code references the table in many of its provisions, mandating completion of the table in order to understand the code requirements. Footnotes to the table provide guidance on how and where the determination of the appropriate information is obtained. It should be noted that the frost line depth should be established by the local jurisdiction based on past practice or available information. Since frost penetration is dependent on soil conditions and elevations as well as expected winter temperatures, it may vary greatly within a limited geographic area. Wind design and limitations. R301.2.1, R301.2.1.1. Buildings and portions thereof shall be constructed in accordance with the wind provisions of the IRC using the ultimate wind speed in table R301.2 as determined from figure R301.2 parentheses 2. The structural provisions of the IRC for wind loads are not permitted where wind design is required as specified in section R301.2.1.1. The wind provisions of the IRC shall not apply to the design of the buildings where wind design is required in accordance with figure R301.2.1.1, or where the ultimate design wind speed in figure R301.2 parentheses 2 equals or exceeds 140 miles per hour in a special wind region. See the exceptions for concrete construction, structural insulated panel construction, and cold form steel frame light construction. The prescriptive wind provisions of the IRC are applicable in most geographical areas as depicted in figure 301.2 parentheses 2, However, when design is required per figure 301.2.1.1 or where the ultimate design wind speed in figure 301.2 parentheses 2 equals or exceeds 140 miles per hour in special wind regions. In such high wind areas, buildings must be designed for wind loads in accordance with one or more of 5 identified methods. Wind loads are a major consideration in designing a structure's lateral force resisting system. In addition, the other building elements are affected as evidenced by provisions for roof tie downs, for example. Windows, skylights, and exterior doors must withstand the component and cladding pressures. Protection of openings, R301.2.1.2. Exterior glazing in buildings located in windborne debris regions shall be protected from windborne debris. See the exception for use of pre-cut wood structural panels with complying attachment hardware. So opening protection in windborne debris regions is usually in the form of permanent shutters or laminated glass that meet the requirements of the Large Missile Test of ASTM E1996 as modified and E1886. The exception provides a prescriptive approach which is only permitted in buildings with a mean roof height of 45 feet or less, where the ultimate design wind speed is 180 miles per hour or less. This method of opening protection uses wood structured panels with a maximum span of 8 feet long with complying fasteners. The builder must pre-cut these panels to fit each glazed opening and provide the necessary attachment hardware. A prescriptive approach for the attachment of the wood structural panels, as described in Table R301.2.1.2, is permitted, but only for buildings with a mean roof height of 45 feet or less, where the ultimate design wind speed is 180 miles per hour or less. As you can see, this is a diagram of a potential pre-cut wood structural panel, and it's got the fastener locations, and the builder has to provide those fasteners as well. Wind exposure category, as referenced in IRC R301.2.1.4. For each wind direction considered, an exposure category that adequately reflects the characteristics of ground surface irregularities shall be determined for the site at which the building or structure is to be constructed. For any given wind direction, the exposure in which a specific building or other structure is sited shall be assessed for being in exposure category B, C, or D. In addition to wind speed, wind loading on structures is a function of the site's exposure category. The exposure category reflects the characteristics of ground surface irregularities and accounts for variations in ground surface roughness that arise from natural topography and vegetation, as well as from constructed features. Additional requirements apply for those local areas where historical data indicate that significant wind speed has occurred at isolated hills, ridges, and escarpments. Exposure B should be used unless the site meets the definition for another category of exposure. Exposure B includes urban and suburban areas, wooded areas, and other terrain with numerous closely spaced obstructions having the size of single-family dwellings or larger. Seismic provisions, as referenced in R301.2.2 and R301.2.2.1. The seismic provisions of the IRC shall apply to townhouses in seismic design categories D0, D1, and D2, and detached 1 and 2 family dwelling in seismic design categories D0, D1, and D2. Buildings shall be assigned a seismic design category in accordance with figure R301.2.2.1 parentheses 1 through R301.2.2.1 parentheses 6. Earthquakes generate internal forces in a structure due to inertia. These forces can cause a building to be distorted and severely damaged. The objective of earthquake-resistant construction is to resist these forces and the resulting distortions. Buildings are deemed to be located in one of several seismic design categories, ranging from Category A to Category E. Buildings in Category A and B, as well as detached 1 and 2 family dwellings in Category C, perform satisfactorily when constructed in accordance with the basic prescriptive provisions of the IRC. On the other hand, Category E buildings must typically be designed in accordance with the seismic provisions of the International Building Code. The inertial force resisting change in motion. Inertial force act in a direction opposite to the direction of acceleration. The earthquake force accelerating house in a horizontal plane, direction of acceleration is reversible. Because the calculation of seismic loads on structures is based on a percentage of the dead load, the IRC prescriptive seismic provisions are based on an assumed dead load. The building dead loads of section R301.2.2.2 are reflected in the prescriptive design tables throughout the code. Irregular buildings. IRC R301.2.2.6. The seismic provisions of the IRC shall not be used for structures located in seismic design category C, D0, D1, and D2, and considered to be irregular. A building or portion of a building shall be considered to be irregular when one or more of 8 specific conditions occur. See the 8 possible conditions. Irregular structures or irregular portions of structures shall be designed in accordance with accepted engineering practice to the extent the irregular features affect the performance of the remaining structural system. Conventional light frame construction typically allows cantilevers and offsets within certain limits in order to accommodate common design features and options. These features are not well suited to resisting earthquake loads. This becomes more of a concern in areas of higher seismic hazard. So portions of buildings are considered irregular when one or more of 8 listed conditions exist. Exterior shear wall lines or braced wall panels not in one plane vertically from foundation to uppermost story where required, exception for limited cantilevers and setbacks. Section of floor or roof not laterally supported by shear walls or braced wall lines on all edges, except for limited extension beyond shear wall or braced wall line. End of braced wall panel occurs over an opening below and ends more than 1 foot from edge of opening, exception for opening with complying header. Opening in a floor or roof exceeds 12 feet or exceeds 50% of the lease floor or roof dimension. Portions of floor level vertically offset, exceptions for framing directly supported by continuous foundations or floor framing lapped or tied together. Shear walls and braced wall lines do not occur in 2 perpendicular directions. Stories above grade plane braced by wood wall framing include masonry or concrete construction, except for fireplaces, chimneys, and masonry veneer. Hillside light frame construction, where 3 specified conditions exist, except for light frame construction, where the lowest frame floor is supported directly on concrete masonry walls over the full length of all sides except the downhill side. The IRC is consistent with the IBC, identifies building features that are considered irregular and not permitted under conventional light frame construction, provisions for seismic design categories C, D0, D1, and D2. Snow loads and roof loads. IRC R301.2.3 and R301.6. Wood frame construction, cold form steel frame construction, and masonry and concrete construction, and structural insulated panel construction in regions with ground snow loads of 70 pounds per square foot or less shall be in accordance with chapters 5, 6, and 8. Buildings in regions with ground snow loads greater than 70 pounds per square foot shall be designed in accordance with accepted engineering practice. The roof shall be designed for the live load indicated in table R301.6 or the ground snow load indicated in table R301.2, whichever is greater. The prescriptive tables for floor, wall, and roof construction are limited to buildings constructed in areas having a maximum of 70 pounds per square foot snow load. Structures in regions exceeding this limitation require an engineered design for all elements that carry snow loads. The basic 20 pounds per square foot live load may be reduced based on the tributary area supported by any structural member of the roof, but no reduction is permitted for snow loads. For roofs, both the live load and snow load must be considered, with a more restrictive loading condition used. The live load takes into account that individuals and materials may be present on the roof during roofing operations. Floodplain construction. IRC R301.2.4. Buildings and structures constructed in whole or in part in flood hazard areas, including A or B zones, as established in table R301.2, and substantial improvement and restoration repair and substantial damage of buildings and structures in flood hazard areas shall be designed and constructed in accordance with section R322. Buildings and structures located in whole or in part in identified floodways shall be designed and constructed in accordance with ASCE 24. Application of the flood provisions of the code cannot prevent or eliminate all future flood damage. Rather, the provisions represent a reasonable balance of the knowledge and awareness of flood hazard methods to guide development to less hazard-prone locations, methods of design and construction intended to resist flood damage, and each community's landowners and reasonable expectations of land use. The flood hazard areas shown on FEMA maps are determined using the base flood, which is defined as having a 1% chance of occurring in any given year. The maps do not show the worst case flood nor the flood of record, which usually is the most severe in history. Story height, R301.3. The wind and seismic provisions of the IRC shall apply to buildings with story heights not exceeding the following. 1. For wood wall framing, the story height shall not exceed 11 feet 7 inches, and the laterally unsupported bearing wall stud height permitted by table R602.3, parentheses 5. 2. For cold form steel wall framing, the story height shall not be more than 11 feet 7 inches, and the unsupported bearing wall stud height shall not be more than 10 feet. 3. For masonry walls, the story height shall not be more than 13 feet 7 inches, and the bearing wall clear height shall not be greater than 12 feet. 4. For insulating concrete form walls, the maximum story height shall not exceed 11 feet 7 inches, and the maximum unsupported wall height per story as permitted in section R608 tables shall not exceed 10 feet. And 5, for structural insulated panel walls, the story height shall not be more than 11 feet 7 inches, and the bearing wall height per story as permitted by section R610 tables shall not exceed 10 feet. The section identifies the maximum story heights used for the IRC's prescriptive provisions. These requirements are height limiting solely due to the prescriptive structural limitations of the code. Such story heights may be increased, though, through the engineered design provisions in the International Building Code. Getting into live loads now. IRC R301.5. The minimum uniformly distributed live load shall be provided in table R301.5. Table R301.5 provides the minimum live loads based on the use of a particular area or portion of a structure. These loads must be considered for the design of corresponding structural elements of any residence constructed under the code. For instance, bedrooms, which are sleeping rooms, require the use of a minimum 30 pounds per square foot live load, whereas all other rooms must be designed for at least 40 pounds per square foot uniform live load. Exterior balconies and decks are to be designed for a minimum 40 pounds per square foot live load. Guardrails and handrails must be designed for a single 200-pound concentrated load applied in any direction along the top of the rail. In addition, the infill components of a guard system, such as intermediate rails, must be designed to withstand a minimum 50-pound load applied on a 1 square foot area. Attic design loads vary based on a variety of factors. Where it is assumed that there is insufficient clearance or headroom to accumulate significant storage, only 10 pounds per square foot is mandated. Where storage is more probable due to a sizable attic height, a 20 pounds per square foot dead load is to be used. A 30-pound minimum uniform live load is required in those attics considered habitable by Section 202, or if attic access is provided by fixed stairs. Exterior walls, 302.1. Construction projections, openings, and penetrations of exterior walls of dwellings and accessory buildings shall comply with table R302.1, or dwellings equipped throughout with an automatic sprinkler system installed in accordance with section P2904 Plumbing Code shall comply with table R302.1, 2. See the exceptions for 1. Excuse me. Those elements perpendicular to the measurement of fire separation distance. 2. Opposing walls of 2 buildings on the same lot. 3. Detached sheds and similar structures that are exempt from permits. Or 4. Detached garages located within 2 feet of a lot line. And 5. Foundation vents. Where an exterior wall of a sprinkler building has a fire separation of less than 3 feet, it is mandated that the wall be a minimum 1 hour fire resistance rated construction. The fire resistive rating must be obtained from the outside of the wall and comply with either ASTM E119 or UL263. In those situations where the building is not sprinkled, a fire resistance rated exterior wall is mandated where the building has a fire separation distance of less than 5 feet. In all cases, exterior walls, projections, openings, and penetrations in such walls located perpendicular to the line used to determine the fire separation distance are not regulated. Regardless of their location, storage sheds and similar accessory buildings that do not exceed 200 square feet in floor area are not required to be provided with fire resistance rated exterior walls. Townhouses. IRC 302.2 Fire Resistant Construction. Common walls separating townhouse units shall be assigned a fire resistance rating in accordance with item 1 or 2 and shall be rated for fire exposure from both sides. Item 1 requires a minimum 1-hour common wall where a fire sprinkler system is provided. Item 2 requires a minimum 2-hour common wall where no fire sprinkler is provided. Common walls shall extend to and be tied against the exterior sheeting of the walls, or the inside face of exterior walls without stud cavities, and the underside of the roof sheeting. The common wall shared by 2 townhouse units shall be constructed without plumbing or mechanical equipment, ducts or vents other than water-filled fire sprinkler piping in the cavity of the common wall. Consistent with the fire separation requirements for other types of multifamily structures, each dwelling unit in a townhouse building must be isolated from the other units for fire resistance purposes. Separation shall be rated for fire exposure from both sides and extend to and be tied against exterior walls and the underside of the roof sheeting. Fire resistant construction has to go from the basement all the way up and tie into the roof structure and tight to the sheeting. As an option to the use of common walls, each townhouse unit shall be separated from other townhouse units by 2 1-hour resistance rated wall assemblies. Two-family dwellings or duplexes. IRC 302.3, 302.3.1. Dwelling units in two-family dwellings shall be separated from each other by a wall and or floor assemblies of not less than 1 hour fire resistance rating when tested in accordance with ASTM E119 or UL 263 or section 703.2.2 of the IBC. See the exceptions for a reduction rating to half hour for fully sprinkled buildings and to a revised method of protection at the ceiling. Such separation shall be provided regardless of whether a lot line exists between the 2 dwelling units or not. When floor assemblies are required to be fire resistance rated by section R302.3, the supporting construction of such assemblies shall have an equal or greater fire resistance rating. So the code mandates a limited degree of fire separation to protect the occupants of one dwelling unit from the actions of their neighbor. Where the units are side by side, the separation wall must extend vertically to the underside of the roof deck. As an option, the continuance of the 1 hour wall through the attic space, the ceiling can be protected with a minimum 1 hour layer of 5/8 inch type X gypsum board, and the attic space need only be separated with a complying draft stop. Where one unit is located over the other, the fire-rated floor ceiling assembly, must extend to and be tied against the exterior walls. The required fire resistance rating of 1 hour shall be verified by compliance with ASTM E119 or UL 263, mandating an assembly constructed in accordance with its listing. As you can see here, the duplex, side-by-side duplex, has the 1 hour assembly between them from the foundation all the way up to the roof sheathing. In this duplex configuration, it's from the foundation to the top of the wall lines, and then having a 5/8 type X drywall at the ceiling creates that 1 hour fire barrier into the combined attic space. So it's a shared attic space. In this situation where the dwellings are one's dwelling above another one, the 1 hour fire assembly has to be between the floor and the ceiling, and it goes tight from wall to wall. If a horizontal separation is provided, elements such as bearing walls and columns that support the separation must also have a 1 hour fire resistance rating. It is of little value to provide a complying floor or ceiling assembly that quickly fails structurally because of unprotected supports. Garage opening protection, R302.5.1. Openings from a private garage directly into a room used for sleeping purposes shall not be permitted. Other openings between the garage and residence shall be equipped with solid wood doors not less than 1 3/8 inches in thickness, solid or honeycomb steel doors not less than 1 3/8 inches thick, or 20-minute fire-rated doors. Doors shall be self-latching and equipped with self-closing or automatic closing device. Although gypsum board or other approved material provides adequate fire separation at the walls and or ceiling between the garage and the dwelling unit, it's important that any other openings penetrating the separation be appropriately protected. Therefore, the type of door construction or fire rating of the door is mandated. Because the code covers only the door itself, it is not necessary to have a complete fire-rated door assembly, but it is a requirement to provide a self-closing and self-latching device. The level of separation provided by the door is consistent with that provided by the gypsum board installed on the garage side. Here you can see some openings going through the roof up into a habitable room from this furnace, into going through the wall there. Where any duct passes through the gypsum board membrane located on the garage side of the separation, the duct material must be a minimum of 26 gauge sheet steel. There must be no openings in the duct within the garage area. These can go into the habitable spaces, but there can be no openings inside this garage area. Dwelling garage separation, 302.6. The garage shall be separated as required by table R302.6. Openings in garage walls shall comply with section R302.5. The wall separation provisions of table R302.6 shall not apply to garage walls that are perpendicular to the adjacent dwelling unit wall. It is not uncommon for a fire to start in a private garage attached directly to a dwelling unit. In many cases, the fire may grow and go unnoticed for a period of time, becoming a distinct hazard to the residents and its occupants. The code mandates a minimum level of fire separation from the garage to the dwelling unit to allow the residents time for escape. In addition, the separation may be adequate to restrict the spread of fire to the dwelling unit until the fire can be controlled and extinguished. The provisions regulating garages are applicable where the space is enclosed on at least 3 sides. Where enclosed on 2 sides or fewer, the parking area is considered a carport and separation requirements do not apply. Wall and ceiling finishes. Wall and ceiling finishes shall have a flame spread classification of not greater than 200. See the exceptions for trim, doors, and windows, and very thin materials cemented to wall or ceiling surface. Wall and ceiling finishes shall have a smoke developed index of not greater than 450. Tests shall be made in accordance with ASTM E84 or UL 723. The control of interior finish materials is an important aspect of fire protection. The dangers of unregulated interior finish include both rapid spread of fire and the contribution of additional fuel to the fire. Rapid fire spread presents a threat to the building occupants by limiting or denying their exit travel. This can be caused by either rapid spread of the fire itself or by the production of large quantities of dense black smoke that obscures the exit path or makes movement difficult. The installation of materials that will not significantly contribute to fire conditions is permitted. Trim, door, and window frames and baseboards are not regulated because of their limited quantity. Thin materials such as wallpaper are allowed as they tend to perform similar to their backing. So here's your flame spread index for these various different types of materials. Fire protection of floors, R302.13. Floor assemblies not required elsewhere in this code to be fire resistance rated shall be provided with a 1/2-inch gypsum wallboard membrane, 5/8 inch wood structural panel membrane, or equivalent on the underside of the floor framing member. See the exceptions for floor assemblies. 1. Located directly over sprinkler space. 2. Located directly over a crawl space, not intended for storage or fuel fired or electrically powered heating appliances. 3. Of limited size where fire blocked, and 4. Constructed with minimum 2x10 dimensional lumber, structural composite lumber, or equivalent. The application of gypsum wallboard or other approved material on the underside of floor framing members provides some protection to the floor system against the effects of fire and delay collapse of the floor. The protection addresses concerns for firefighter safety and incidents of injury or death to firefighters due to floor collapse while fighting residential fires. The emphasis is placed on light frame floor construction consisting of I-joists, manufactured floor trusses, cold form steel framing, and other material and manufactured products suddenly most susceptible to failure during a fire. Floors framed with solid sawn lumber and structural composite lumber of substantial size are exempt because they perform fairly well in retaining adequate strength under fire conditions. Similarly, if sprinklers are installed to protect the space below the floor assembly, membrane protection is not required. Exceptions also address crawl spaces without storage and small areas. All right, we are ready for our quiz. What is the weathering probability for concrete for all dwelling sites located in the state of South Dakota? Is it severe, moderate, negligible, or none? Our answer is A, severe. I thought I could get it to come up. So our figure R301.2 parentheses 1 is the weathering probability for concrete. You can kind of see the map there just a little bit. Two, what is the range of the ultimate design wind speeds to be used in South Dakota? Again, we're going to look for a figure with a map. So what's the range of the ultimate design wind speeds to be used in South Dakota? Is it 1 to 105, 105 to 110, 110 to 114, or 115 to 120? The answer is C, 110 to 114. Let's see if I can get it to come up. Here's our weathering probability map for concrete. And here's our wind speeds. Here's our South Dakota region. All right, number 3. Based on figure R301.2.3, what is the ground snow load for most of western Colorado? Is it 30 pounds per square foot, 40 pounds per square foot, 50 pounds per square foot, or is it site specific due to extreme local variations? It's going to be D. It's going to be site specific due to extreme local variations. 4. Unless local conditions warrant otherwise, what is the probability for termite infestation for dwellings constructed in most of Idaho? Is it very heavy, moderate to heavy, slight to moderate, or none to slight? The answer is C, reference section figure R318.4. For the purpose of determining the component and cladding loads on the roof surface of a building, the area at the ridge of a gable roof sloped at 20 degrees shall be considered as pressure zone what at the other eaves? Is it 1, 2, 2R, or 3E? It's C. You're going to find that in section figure R301.2.1. As we're going through this, I'm hoping you have your code book open and you're looking at for these answers. I know I'm going through them quickly, but hopefully you're having a chance to take a look at those, and feel free to stop the video, take a look for the answer, and move on from there. Where wood structural panels are used to protect windows in buildings located in windborne debris regions, number 8 wood screws shall be located a maximum of how far on center to fasten those panels that span 8 feet? Is it 8 inches, 9 inches, 12 inches, or 16 inches? Our answer is going to be A, 8 inches, and that's going to be based on table R301.2.1.2. Question number 7. Where a reference document is based upon nominal wind design speeds and no conversion between ultimate design wind speeds and nominal design wind speeds is provided, an ultimate design wind speed of 115 miles per hour shall be converted to a nominal design wind speed of what? 85 miles per hour, 89 miles per hour, 93 miles per hour, or 101 miles per hour? Our answer is B, 89 miles per hour. You're going to get that from table R301.2.1.3, which is the wind speed conversions. What wind exposure category is appropriate for a dwelling located in a residential development in a suburban area? Is it A, B, C, or D? The answer is B, exposure B, and that's going to be section R301.2.1.4. The seismic design category for a site having a calculated load is what? B, D0, D1, or E? Our answer is B, D0. You're going to get that from table R301.2.2.1.1, which is our seismic design category determination. Number 10. Habitable attics shall be designed with a minimum uniformly distributed live load of how many pounds per square feet? Is it 10, 20, 30, or 40 pounds per square feet for a habitable attic? Our answer is C, 30 pounds per square feet of distributed live load. You're going to get that in table 301.5, which is our minimum uniformly distributed live loads in pounds per square foot. For a dwelling assigned to seismic design category D2 and constructed under the conventional provisions of the IRC, what is the maximum dead load permitted for 8-inch thick masonry walls? Is it 40 pounds per square feet, 60 pounds per square feet, 80 pounds per square feet, or 85 pounds per square feet? The answer is C, 80 pounds per square feet. You're going to get that from section R301.2.2.2, number 5, which is the weights of materials. Number 12. A portion of a building is considered irregular for seismic purposes when a floor opening, such as for a stairway, exceeds the lesser of 12 feet, or what percent of the least floor dimension? Is it 15%, 25%, 33.33%, or 50%? Our answer is D, 50%. We're going to get that from section R301.2.2.6, number 4, which is the irregular buildings. Buildings constructed in regions where the ground snow load exceeds a minimum of how many pounds per square foot must be designed in accordance with accepted engineering practice? Is it 30, 50, 70, or 90 pounds per square feet? The answer is C, 70 pounds per square feet. You're going to get that in section R301.2.3, which is snow loads. For rooms other than sleeping rooms, what is the minimum uniformly distributed live load that is to be used for the design of the floor system? Is it 20 pounds per square feet, 30 pounds per square feet, 40 pounds per square feet, or 50 pounds per square feet? Our answer is C, 40 pounds per square feet. You're going to get that from table R301.5, which is our minimum uniformly distributed live loads. Question number 15. A minimum uniformly distributed live load of 10 pounds per square feet is to be used for the design of uninhabitable attic areas without storage, having a maximum clear height between the joists and the rafters of how many inches? Is it 30 inches, 36 inches, 42 inches, or 60 inches? Our answer is C, 42 inches. You're going to find that in table R301.5, note B, which is the minimum uniformly distributed live loads in pounds per square feet. Number 16. A minimum uniformly distributed live load of how many pounds per square feet shall be used for the design of sleeping rooms? Is it 10 pounds per square feet, 20 pounds per square feet, 30 pounds per square feet, or 40 pounds per square feet? Our answer is C, 30 pounds per square feet. Again, you're going to find that in table R301.5, the minimum uniformly distributed live loads. Where no snow is present, what is the minimum roof design load for a 240 square foot tributary loaded roof having a slope of 8 inches per 12 inches? Is it 20 pounds per square feet, 16 pounds per square feet, 14 pounds per square feet, or 12 pounds per square feet? Our answer is C, 14 pounds per square feet. You're going to find that in table R301.6, which is the minimum roof live loads in pounds force per square foot of horizontal projection. What is the maximum allowable deflection for floor joists? Deflection is that. Is it L to the 120th, L divided by 180, L by 240, or L by 360? The answer is D, L by 360. You'll find that in table R301.7, which is the allowable deflection of structural members. The maximum allowable deflection permitted for a 712 sloped rafter with no finished ceiling attached to the rafters is what? A, L120, B, length divided by 180, C, length divided by 240, or D, length divided by 360. Our answer is B, length divided by 180. Again, table R301.7, allowable deflection of structural members. Question number 20. A fire resistance rating is not required for exterior walls of non-sprinkler dwellings having a minimum fire separation distance of how far? 3 feet, 4 feet, 5 feet, or 10 feet? The answer is C, 5 feet. You're going to get that in table R302.1, parentheses 1, which is exterior walls. A roof projection on a dwelling shall be located a minimum of how far from an interior lot line? 0 feet, meaning it can be extended to the lot line, 12 inches, 2 feet, or 4 feet? Our answer is C, 2 feet. You're going to get that in tables 302.1, parentheses 1, which is exterior walls, or 302.1, parentheses 2, which is exterior walls dwellings with fire sprinklers. Tool and storage sheds, playhouses, and similar accessory structures having a minimum floor area of how many square feet are not required to have exterior wall protection based on location on the lot? Is it 100 square feet, 120 square feet, 150 square feet, or 200 square feet? Our answer is D, 200 square feet. You're going to get that in section R302.1, which is exterior walls, exception 3, and R105.2, number B, which is work exempt from a permit. Walls and ceiling finishes shall have a maximum flame spread index of what? 25, 75, 200, or 450? The answer is C, 200. I'm going to get that from section R302.9.1, which is our flame spread index. We're located in an exterior wall having a minimum required fire resistance rating of 1 hour through penetration shall be protected with an approved penetration fire stop system having a minimum F rating of how long? 20 minutes, 30 minutes, 45 minutes, or 1 hour? The answer is D, 1 hour. I'm going to get that in section R302.4.1.2, penetration fire stop system. Where a detached garage is located within 2 feet of a lot line, the maximum eave protection is limited to how many inches? 4, 6, 8, or 12? Our answer is A, 4 inches. You can get that from section R302.1, which is exterior walls, exception number 4. For wind speed purposes, a building located along the shoreline in the Great Lakes region is categorized as exposure what? Where exposed to wind coming from over the water. Is it wind exposure A, B, C, or D? Our answer is D, and you're going to get that from section R301.2.1.4, number 3, which is our exposure category. All right, so which of the following buildings is exempt from seismic requirements of the IRC? Is it a townhouse in seismic design category C, A one-family dwelling in seismic category design category C, townhouse in seismic design category D0, or a two-family dwelling in seismic design category D1? The answer is B, a one-family dwelling in seismic design category C. You get that from section R301.2.2, number 2, which is our seismic provisions. Where solid wood door is installed as permitted opening between a garage and a residence, the minimum thickness of the door shall be how many inches? 1 3/8, 1 1/2, 1 5/8, or 1 3/4? Our answer is A, 1 3/8. Section R302.5.1, which is opening protection. When a common wall is used to separate townhouses provided with a fire sprinkler system in accordance with section 2904, it shall have a minimum of what fire resistance rating? Is it 1 hour, 2 hour, 3 hour, or 4 hour rating? Our answer is A, 1 hour rating. We're going to get that in section R302.2.2, number 1, which is common walls. An infill panel for a guard shall be designated to withstand a minimum load of how many pounds applied horizontally on an area of 1 square foot? Is it 50 pounds, 80 pounds, 100 pounds, or 200 pounds? The answer is A, 50 pounds. We're going to get that in table R301.5, note F, which is our minimum uniformly distributed live loads. Number 31, where structural wood panels are used to provide windborne debris protection for glazed openings, the fasteners shall be long enough to penetrate through the sheathing and into the wood wall framing a minimum of how many inches? Is it 1 inch, 1 1/2 inches, 2 inches, or 2 1/2 inches? Our answer is C, 2 inches. You're going to get that from table R301.2.1.2, note C, which is windborne debris protection fastening schedule for wood structural panels. In the determination of the allowable deflection for cantilevered structural members, L shall be taken as what the length of the cantilever? Is it the actual length, 1 1/2 times the length, twice the length, or 3 times the length as the cantilever? The answer is C, twice the length. You're going to get that from table R301.7, note B, which is our allowable deflection of structural members. Number 33, attic spaces served by a fixed stair shall be designed to support a minimum live load of what? 10 pounds per square foot, 20, 30, or 40? This is attic spaces served by a fixed stair shall be designed to support a minimum live load. The answer is C, 30 pounds per square feet. We get that from table R301.5, which is our minimum uniformly distributed live loads. Number 34, unless listed for lesser clearances, combustible insulation shall be separated a minimum of how many inches from recessed luminaires, fan motors, and other heat-producing devices? Is it 1 inch, 3 inches, 4 inches, or 6 inches? Our answer is B, 3 inches. We're going to get that from section R302.14, which is combustible insulation clearance. Last but not least, number 35. The aggregate area of openings in an exterior wall of a non-sprinkler dwelling located with a fire separation distance of 4 feet is limited to the maximum of what percent of the exterior wall area? Is it 10%, 25%, 50%, or 100%? Our answer is B, 25% of the exterior wall area. We're going to get that from table R302.1, parentheses 1, which is exterior walls. Once again, I want to thank you for joining me on our trip through the 2021 International Residential Code. I look forward to having you back for our next study session.